everyone. Today I'm going to talk about um, what bringing games on chain means and how on chain games unlock new kind of gaming experience or like even help in some ways expanding the gaming space, gaming industry in general. And all of that is possible because of the zero knowledge technology and zkVMs like Starknet and some other which might be in development. So first, let's talk about why Web3 games. Why do they matter? Or sometimes we call them on-chain games as well. So on-chain games promise a new kind of world. Uh, in this world, the games provides true ownership to the users. Uh, what do we mean by ownership? Like users truly own their in-game items. It could be uh, like a sword in a game you have, or it could be in-game currencies you have. So users or players can use these assets freely. They can use these assets outside of the game as well. They can take it outside of the game, can sell these assets in an open market as well. uh, the second benefit is hardness. So I'm not sure how many people are familiar with Vitalik's story into Bitcoin, like how he came to found Ethereum. So essentially, like he used to play a game a lot, and he lost access to one of his game item, uh, and that made him really sad. And basically, it made him think like if there could be a way in which like the rules of the game, he can have a surety on like the rules of the game, like this is what is going to follow. So hardness means like players can be assured that the algorithm of a game, the rules of a game doesn't change arbitrarily, that there is a due process of changing the rules, and players are upfront know about that. And at the same time, like with on-chain games, it also gives players freedom in terms of if a game changes their rules, like in some kind of consensus, the players can fork the game, keep the original logic of the game, and keep playing the original game. So there can be like two alternative version of the same game. So it gives that freedom of fork, and as a result, like player are always in control of what they are exactly playing. The third benefit is composability. So just like in DeFi, the biggest benefit of DeFi has been composability, where a smart contract of Aave can use the smart contract of Uniswap to use the swap functionality. So similarly, in case of games, on-chain games will enable the composable world where one game can use the logic of another game into its own smart contract. For an example, imagine like you are playing a game of Minecraft, and in that game of Minecraft you might have a function called run. uh, Someone can create a micro game and use the run function which was actually used in the Minecraft game, and they use the same function in their own game. So like different like games can start collaborating in a very different way, where like different smart contracts are using code of other smart contracts. And the fourth and one of the most important is privacy. So privacy is something like which doesn't exist today at all in any gaming world. Where it matters, for an example, like a game of poker, you don't want to reveal what cards you hold to your opponent, or even to a server, like because you don't know somebody who is having access to the server can start playing against you as an opponent. So they have access to your cards and they can play unfairly against you. So on-chain games or Web3 games enable all these benefits. Like on a metaphorical level, like they basically bring the same thing to games what DeFi brought to finance. Like DeFi made finance more open, composable, uh, something which is like they can expect like hardness and like a lot of other things. Similarly, on-chain games all these benefits to the gaming world. But building on-chain games is really hard. Especially, it's really hard with EVM and languages like Solidity. And thanks to the newer applications or newer implementations of zkVMs, one of the example is Starknet. They help some of the challenges. So we'll go into like what are the challenges and like how it is solved by ZK and zkVMs like Starknet. So one of the biggest challenge when you are creating games on something like Solidity, using Solidity is so Solidity was never optimized to build complex applications. Solidity was created 7 years ago. It was created in the constraint of what could be on chain, and in that world, like when Ethereum was trying to do everything on chain, from settlement to execution to data storage, everything. And now we are moving into an you can say layer 2 world where you are trying to bring computation off chain and settlement on chain. But Solidity was never designed keeping these kind of applications in mind. So as a result, Solidity had this arbitrary restriction in terms of contract size. What could be the maximum file size of a contract, of a smart contract? Because of that, like it doesn't matter for DeFi applications, because DeFi applications are usually smaller applications, simpler applications in terms of logic. But when you are writing gaming applications, you might have a much larger code base. So for that, people who are creating games in Solidity, they come up with these hacky solutions. One of these solution is called diamond pattern. So you start splitting your code into multiple different smart contracts arbitrarily. Now imagine like you are creating a game, and as a game developer, all you want to care about is like you can easily write the functions, the logic of the game. But now you have to take care of, okay, the context size as well. Okay, this file size could be maximum this. So you start splitting the code into different files, and then your code becomes really messy, because like some part of the code is somewhere and some part of the code is somewhere else. So it becomes really messy writing code with Solidity. Like some of the layer 2 solutions are coming up with their own ZK native languages. So Cairo is one example. So Cairo is built, it's a superior language to build large, complex on-chain applications. So why? Because for an example, there is no context size limit, so you can like freely write your code however you want to do. Similarly, like many of the games will want to write zk logic on the client side. Sometimes you want to prove on the client side that I hold this card. You don't want to put that information on chain, because if you put that information on chain, then it becomes public. Everyone knows that. So if you don't want to put it on chain, you need to achieve client side privacy, or you need to basically implement client side zero knowledge logic. So something like that is not possible with Solidity. To achieve that with something like Solidity, you will need to write your own custom circuit with something like Circom as a language, which is very, very complex. Uh, and like, again, as a game developer, you don't want to get into that. So Cairo helps with both. It helps you write logic in a much simpler way, like without any of these limitations. It helps you write ZK logic with the same language. You don't need to learn another language to achieve that. Also, it is optimized for computationally expensive applications. You can write application which require more computation, complex computations. It's optimized for that. Another problem is like you don't get any privacy with public blockchain. So when you are creating games, sometimes you need to have privacy. For an example, if you are playing a game of poker, as I mentioned, you don't want to reveal your cards to your opponent, or not even to a server. So if a game is run on a blockchain, pretty much everyone can see that. So that's where, as I mentioned, client side privacy comes into the picture. And this is possible by Cairo, as I mentioned. So with Cairo, or something similar to that, you can achieve zk proof creation and verification on the client side. By client, I mean like your user's mobile device, or their laptops, or their desktops. So this enables creating poker in a very trustless way where you do not have to trust a server to execute the poker game. Like something like this doesn't exist today. Like even if you are playing at any poker website, you are basically trusting the website to not see your cards and does not play against you. But with this you get the surety because even the server cannot see what cards you hold. So it gives like birth to this completely new paradigm in case of these kind of games. Similarly, like it applies to games like tower defense kind of games as well, where you do not want your opponent to see what kind of defense you have set up, because if my opponent already see what kind of defense I have set up, then I can basically create the opponent can create the counter unit against that defense. So privacy becomes important, and this is enabled by zk and zkVMs. Another problem is Web3. As we all know, Web3 games don't scale well because they rely on the underlying blockchain technology. Like blockchains are not scalable. Uh, if you think about like whole layer two space combined today, like all layer twos combined have done maximum of 70 or 80 transaction per second. If you like do the math, it could be maybe like some millions, few millions, less than 10 million transaction per day. If you think about even one single game, like which could be a very good fit uh, for like on-chain games like Minecraft, that itself has probably 25 million to 50 million daily active users, and that just users. They do billions of actions every day. So blockchains cannot handle any that kind of scale. So uh, how do you solve that? Uh, Again, like you solve that by running your application specific environments, which we call app chains or layer threes. And when you do that, you basically get as much scale as any web 2 application. How? Because now you can run all the computation on an AWS server or like a centralized server. So you do everything on a centralized server, and whatever you do, you create a validity proof of that, and then you submit it on a blockchain. So you do the on-chain validation that yes, uh, all the logic, all the computation that has been done, it was done correctly. So now this gives games the same level of scale as any web 2 game scale, but at the same time with all the benefits of blockchain, like which is it still remains trustless, because if you run the computation incorrectly, then the validity proof will not be valid on chain and the settlement will not happen. And last and not the least, like we know, like Web3 games have really, really bad user experience. Like if we want to reach to a scale where billions of people play games, on-chain games, we cannot imagine like people installing a wallet plugin in their browser, or like approving every single transaction for any in-game action they do. Like let's say you just want to fight with an opponent, sometimes you take out your sword, sometimes you use your special powers and all of that. So imagine like if you need to approve a transaction using your MetaMask or a wallet for each of those in-game action, like it will be like you cannot even imagine that. uh, Another problem is like gas tokens. Like even to do those transactions, you will need native tokens to pay for gas. And like as a game player, why do I care if I have this particular layer two's token or not? And then like seed phrases, one of the worst. Like you lose access to your whole game if you lose access to your seed phrase. So like all of this creates a really bad user experience, and we can never imagine to have millions of users in a game. So all of that is solved by account abstraction that is built natively within the chain, that creates a superior user experience. And that is again something which is done by ZK based or validity rollup, like Starknet. So how, what kind of benefits native account abstraction enables? Like you can have in-app wallets, so you don't need to install a plugin. Instead, you can use in-browser wallet or in-app wallets. Like your uh, application can save the keys within the application uh, for some kind of sessions. You can use multi-call, so you don't need to uh, confirm transaction for every action you do in the game. Instead of that, you can combine all the calls together and you can put one single transaction. To enable that, you usually use something called session keys. Session keys is something like which is very known in web 2 world as well, like where if you log in on Facebook, like it stays logged in for like 2 weeks, even a month. So how that happens is because it stores access tokens. So session keys are similar to that. Session keys give an application access to transact on your behalf within a certificate, within a specific logic which is preset, which like this application can only sign these kind of transaction and for a limited period of time. So this makes it very easy, like you don't need to ever think about there is a wallet. Even like users don't even need to know about if there is a wallet in the back. Similarly, like you can pay for the gas fees on behalf of the users using something called paymaster. This is again another benefit of native account abstraction. uh, and you can use, instead of seed phrases, you can basically sign transaction using secure enclave, which is part of any mobile devices like any iPhone. So you can basically like sign transaction using how like you how you use secure enclave in uh, saving passwords or like using any iPhone applications. So yeah, on-chain games, with including all these benefits, like it creates a new world. It creates harmony between players and developers because it gives birth to an open economy. And whenever you have open economy, they grow 10x larger than the closed economy. So that's about it. Like feel free to check out and feel free to ping me if you want to learn more about on-chain games.
Amazing. Thanks, Rohit. That was really fun to explore from a less technical angle the applications of zk proofs and then also of the zk VM in general. Um, so I got a few questions. I think first about the zk VM, and I think I can go back on these slides here. So we're seeing like quite a few of these virtual machines pop up, and like this dude here building a game with Solidity is clearly unhappy, and he's clearly empowered building a game with Cairo. So you explained a bit like how complex Solidity is and why the architecture is not built for gaming. So what is it about the zk VM? Is it primarily the scalability, or is there other components to the zk VM that make it opportunistic for gaming?
Yeah. So the whole point of virtual machine is running the execution. Like if you think from the fundamental perspective, what is execution? Uh, you want to do some kind of math, some kind of computation, right? So uh, like you now, since like we want to do trustless computation, what trustless mean, that you want to have the maximum resources available. You want to make computation really cheap, because if hundreds of nodes have to run the same computation, like it will cost everyone the server cost, right? As a result, like the games will become very expensive. So instead of that, what you want to do is you want to run the computation on a centralized server, on one single server. You don't want to duplicate the execution, but you want to prove to a blockchain that whatever you did, it was correct. So now for that, you need to basically create a validity proof or a zk proof. So zk VMs are differentiated because they are optimized to create all these kind of computation, uh, compared to EVM is optimized for like running on Ethereum, executing on Ethereum, which is a distributed network. So fundamentally, like one brings the benefit of scalability and one brings the benefit of decentralization. And since with games, you need to achieve insane scalability, you need to achieve for maximum concentration of computation, but at the same time, you need to maximize for trustlessness.
Got it. And that's how we avoid the situation with Vitalik getting nerfed.
Exactly.
Very cool. Okay. And then the other question I had was a little bit off topic from the ZK topic, and a little bit more on one of the concept that we're exploring a little bit further, maybe in our next educational series. But I think this could be a good primer for that. So I'm going to go all the way back to, I think it was slide 10 or 11, or about native account abstraction, because this is something that is available on the zk VM on Starknet. And native account abstraction is not quite available on Ethereum until one of the EIP for account abstraction passes. But we are seeing like certain layers of account abstraction put on top of Ethereum. One of the best examples of this was FriendTech, and they allowed you to sign in with your Twitter. They generated a private key, and you were able to interact with FriendTech, not using a seed phrase, not downloading a browser extension, but just by connecting your Twitter account. So could you explain why Starknet has native account abstraction, and what does the native mean with account abstraction?
Yeah. So when we are talking about EVM, so in EVM, like by default, the account is an EOA, like externally owned account, right? You have seed phrase, and for that you have the for every transaction, like somebody has to confirm a transaction, a human being, somebody has to confirm a transaction. Uh, how you achieve account abstraction in EVM is by having like a layer on top of this. So you create something like what Safe did. Basically, you create smart contracts, and then within that smart contract, you write these logic that okay, these this is how you can basically control this account, this smart contract. Now, like it does give you benefit of account abstraction, but at the same time, like think from the perspective of if you are a user of Ethereum. Now let's say you are using something like MetaMask, how will you differentiate, like if I am a native user or if I am a account abstracted user? Like there are two kind of users now, right? It will by default create conflicting user experience between different applications. Like there will always be conflict, right? It's not built natively. Like so native account abstraction is by default every single account is a smart contract account. So that's what is different in case of Starknet, and it is only possible in non EVM chains, because if you are looking for EVM, then you have to basically replicate the code of EVM, and as a result, you will have you will have to apply 4337 kind of a thing, which is like an abstracted layer on top of the core protocol, which is not the native account abstraction. So this will by default create a unified experience across all applications, and I think that's the way to go, because like at some point of time you will want to have users to have single kind of account. Like if you think about it, Facebook is what someone uses across the different games or different applications. So similarly in games as well, like you will like to see similar kind of experiences where a user will have one social account and they will use it across games or social fi applications or anything.
Got it. Yeah, that makes sense. I think we're all kind of like curious and like patiently awaiting this native account abstraction experience on Ethereum, and it puts the chains that have the native experience a little bit further ahead in terms of the experimentation that can be done. Because yeah, I think we're seeing these at like kind of a fragmented approach on Ethereum, but there isn't quite anything that takes that and runs with it like the fully native unified experience that's currently available on Starknet.
Yeah.
Cool. Okay, I think I got one more question, and then Andy may have some questions as well. Um, going back to this slide about poker, I think is here. So
Yeah.
this is how I got started in Bitcoin and in cryptocurrency. So like this private, so I was playing poker on a site, and it said on the site it was provably fair. And I always thought that was like quite curious, because they had like a bunch of like fancy math there, and it was like provably fair odds on sports and on poker. And at the time this was long before ZK proof technology. This was like 2016, and it said provably fair, and I was like, oh, it's on a blockchain, that makes it provably fair. But I really did not understand how that worked in the back end. So here you did mention that the like in a poker game, like my cards are stored on my device. But then how does, like when it's time to, like when the last card comes up and it's time to show your cards, how does the game know that my cards are ace king and someone else's cards are king queen, and therefore I win the hand? How does the game know
Yeah.
that?
Yeah. So uh, this is where like two things come into the picture. One is the client side zk, and let me explain that. And second is recursion. I'm sure like you have heard of this word as well before. So imagine like we three are playing the game of poker. uh, right now it's my chance and I have some cards, and there are three cards open on the face as well, like open cards, right? So uh, I will play my turn, like I'll say okay, I want to raise or whatever. I will create a zk proof on my device. That zk proof will have information that okay, whatever turn I have played, it basically aligns with the rules of the game. There are rules of the game that could be put into the server, right? Into the application logic. So I'll create a zk proof, I'll send it to you, Robbie. And then Robbie, you will play your turn, you will use my proof, and you will create another proof on top of that. So again, you will have one single proof which was built on top of my proof. Then you will send that proof to Andy. Andy will play his turn and will recreate a proof. And similarly, we will keep playing turns, and every time we will have one single proof, like it will be with the person whoever is having their turn right now. Then let's say the round finishes. At the end of the round, this we will have one single proof. This will go onto the blockchain. It will verify that all the computation was done correctly, because even if uh, one play was wrong, then the proof will not be verified, right? That's the benefit of recursion. So now the benefit of that is like neither I revealed my card, neither you revealed your card, neither Andy revealed his card till the end of the game. And then like the game will finish and you will basically settle on the chain.
Okay,
Does
so
that make sense? Does
I think
does
so. So
does
the
that?
benefit of recursion is that like we don't show our cards until it's time to like show your cards at the end of the game.
Yeah, yeah,
Okay.
yeah, exactly. And for an example, like when I say the verification, if I played the right turn, and when will be done on your device, that when I send you the zk proofs, your device will verify yes, this zk proof is correct. For an example, let's say on the face there are three jacks, right? And I folded. No, I did not fold. Let's say I went all in and I needed to show my cards, and there were like two jacks as well. So now it can't be two jacks, right? So the logic, the zk proof will verify on okay, no, this logic is incorrect. Like this is what the card has to be.
Got it. Yeah, that makes sense. Andy, did you have any questions here?
Um, I just was curious as to why you think that the aspect of zk uh, technology is going to be the end all be all, or the biggest aspect of gaming. Is it because of the privacy? Is it because of this, you can know something without having to know it? Like, what would you say is the biggest reason of all the positives of zk technology that you believe that it's going to lead the charge for gaming?
Yeah, I think like there are going to be two major components which will play a bigger role. Actually not two, actually there could be more, like all the factors I have shared in my slide. So privacy will play higher degree into games which involve money, and like which involves secret, some kind of secret on the player end, so like poker or any kind of like card games. In that case, like privacy is going to be the bigger angle. uh, Composability is going to be the bigger angle for any like world building kind of games. For an example, like Minecraft, Clash of Clans, Age of Empires, all these games are world building games. Uh, in these games, like what you do is like you have these economy, you have items, you have buildings, you have armies and all of that. So it could be used across cross games as well. Like the kind of characters you have, I might use it in my game as well, or the kind of logic you have, I might use it in my game as well. So in these kind of games, I think composability will play a big role. uh, Computation kind of thing, I think will be applied to both. Like whether it's games like like computation is something you will need in most games. So that will be by default a significant benefit of validity rollups. Like again, it doesn't go like only one benefit, right? Because the way you are making games trustless is by using the validity proofs. And if you are using the validity proofs, or if you are using the on-chain games, then you need to solve for the scalability. So scalability will be solved by like off-chain computation layer 3 kind of environments, which is something like we just started seeing getting into the ecosystem now. Like pretty much every major layer 2 ecosystem is working on app chains or layer 3 kind of an ecosystem. So there is going to be a lot of tooling that will help with that. Other than that, I think like some games have this economic nature as well. So again, like in world building games, the economic nature kind of makes a lot of sense, like where you have gold, wood, food, these kind of currencies. So like utilization of cross currencies across different games, like this economic nature will also be a game changer, I think, in some of the games.
Sweet. Yeah, I think we're finally starting to see the pieces come together, which is really cool for some of these hyperscale applications that have the ability to reach millions, if not billions, of users. And we realize it's not the technology that's making that happen. It's the consumer-facing entertainment or information flow or the value that it provides the end user. So, Rohit, this has been yeah.
And like I think like that's how like we will get more users using on-chain applications, like instead of DeFi or financial applications. Like if you think about it, like finance is boring for most people. Like if you will talk to 100 people within your friends group, probably 10 of them will be aware about like how finance work or deal with finance. Like 90% of them will most likely play a game or use a social application. So I think social applications, gaming applications, this is what will bring crypto or like Web3 to billions of users. And some of the shout outs, like I think it's still in early stages in the sense like you still need all these toolings. Like Starknet is, for an example, just 2 year old, and that is just Starknet, and we still need layer threes for like these kind of things to succeed. So layer threes are still not live anywhere as such. There are app chains. App chains are, I think, very new. It's not mature. There are no tooling for like client side zk kind of logic. What I mentioned, like all of these things need to be built, and some of the some of the teams are doing great work. So like one of the team is Dojo, who is basically building like a game tools or tool chain for on-chain games. Think of it like creating Unity or End Engine, things like that, for so that it makes it very easy for game developers to create games.
Yeah, I think we heard of them at Starknet CC this past year. The thing that they gave us a talk, or at least were there. Yeah, super interesting. Yeah, thank you, Rohit, for coming on and sharing your slides and your presentation about zk and how it's going to play an impact. And I think we can all agree that, yeah, gaming is going to be a huge sector to onboard a ton of people without even knowing that they're using zk technology, which is exciting. So thank you.
Yeah, thanks, Andy. Thanks, Robbie.